So I know what you're thinking. You're thinking, where in the heck did all those numbers come from? Well, you have the data in the problem, right? So all you need to do is type it up into Excel or StatCrunch. Let me show you. Poof, there it is. All right, so X bar would be equal to average of the data. S was the standard deviation, so it'd be equal to STDEV. Okay, old school would just be STDEV. New, it'd be STDEV.S. They're trying to make it more clear that it's the sample one, which is why well past time in my personal opinion. There we go. See, and that's where I got the 5.702. Look at the formula. 5.702, that's my X bar. 5.72 is the mu zero, the null hypothesis. 0.04965 is my S. And while I'm on the subject N, I mean, I know I could count it, but why bother when I can just say count? And it'll count how many there are there. Awesome, huh? All right, so, oops, that's X bar, S, and N, and that's where I filled them into the formula. Now, to find the T0, which is my test statistic, I'll just put it right here, T0. That's equal to parentheses X bar, ooh, hold on. Let me put mu 0 in here for a second. Mu 0 was 5.72, correct? All right. So now T0, that test statistic, is equal to parentheses 5.702, which was D1, minus, there we go, D4, close parentheses, divided by parentheses S divided by SQRT of N. Close my other parentheses, enter. And there you go. It's negative 1.519. Let me type that in. Equals negative 1.519. Cool. I think we're all set with that. Let's go back to the Word document and double check. Okay, so we found our test statistic right here, negative 1.519. Now we're using the classical method. So we're going to need a picture that looks a lot like this. Oops, classical, this, excuse me. But it's going to be T's instead of Z's. So let me go get that. All right, there it is. Now let's think about this for a second. Alpha is the area in both tails, right? Because this is a two-tailed test, then we want alpha over 2. So let's write all that. So alpha is, I suppose alpha is right here. And we can do alpha divided by 2 right here. So alpha was 0.05, so alpha over 2 is that divided by 2, if you really wanted to know. Okay, so we need T, oopsie, I think I pressed the caps lock there. T alpha over 2, lower one, right? I better make that lower. And then we're also going to need another one that's the T alpha over 2 that's for the upper. Now, there's a lot of ways to do this. There's the old school T inverse function, which if you're stuck with that, it kind of is not my favorite. So let me do my one first. So T dot, all right, now you see I've got T dot inverse or T dot 2T. The beautiful thing is that since this is a two-tailed test, I can use the two-tailed one, and then I can use alpha over 2, oh no, wait, alpha. Right, alpha. So you tell it D6, which is the alpha value. And because it knows it's 2T, it knows to split it up for you. And degrees of freedom would be N take away 1. There you go. And now this is technically the upper one. So here, there you go. Typed it in. And this value would just be the opposite of that. It'd be negative, oopsie, negative of that value. Okay. Poof. It took me a second. I had to remember how to do it. T inverse is the same thing. You go T inverse D6, which would be alpha, comma, D3 minus 1, which is your degrees of freedom, and you get the same number. And then to find the other one, you can just take the opposite of that. Okay? So T inverse dot 2T, so T dot INV dot 2T is the new function, or TINV is the old function. But either way, those are your critical values. Poof, and that's what your graph should look like. Alpha is the area in both tails. You got one critical value up here and another one down here, and they're the same number. It's just they're opposites of each other because it's symmetric.